Okay, so we're going to go through our final set of notes through this packet. So on the inside cover, you're going to see the calendar. Today, we're going to start curve sketching, and then we'll do some more on Thursday, but tomorrow is your trig quiz. I will have worksheet 5 for you to pick up if you'd like to have an extra worksheet to work on tonight, but I'll also have a help session tomorrow morning, 7:15. I'll also send out a link through Teams or through Remind if you want to join online tomorrow for that morning review. Calculator is not required, but graphing calculator is not required, but it helps to be able to see the graph. And so if you can have your graphing calculators out, I do have a couple that you can borrow, but let's go ahead and have our calculators out. So let's go to page 2. I'm going to save the mean value theorem and roles for Thursday. I feel like what's more challenging is the curve sketching and just getting used to all that. So let's go to page 2. By the way, the key is attached, so you can always look ahead to if you want to see how your work is coming out. Okay, so we're on page 2. Given that our function y is equal to x minus 2 cosine x. So in your graphing calculator, you can go to y equals. So y equals is this top left-hand button here. Y equals. Here you can enter in a function and you can ask the calculator to graph it for you. So let's see what this looks like here. For x minus 2 cosine x. The button X is near the top of your calculator there. There's multiple variables here, but we're only going to use variable X. But you don't have to worry about, if you click this button, it will always give you X. Next up, let's go to mode. Make sure that we're always in radian mode. Anytime we're using calculator, and anytime we're involving trig, we're always going to be in radian mode, never in degree mode. So you can always go and scroll down. If your degree is highlighted, you can just scroll and just make sure that your radian is the one that's highlighted. Okay, so let's go to Zoom. So this will allow you to get a standard view of the graph. So this, if you go to Zoom 6 standard, this will give you a -10 to 10 window so that your X and Y axis will extend from -10 to 10 from left to right, as well as from bottom to top. It's not always going to fit the graph, but this is where I like to begin to see what my graph looks like. So Zoom 6. I don't think I did that right. Let me try it again. So Zoom 6, you're going to hit enter. Okay, so again, you're going to go to y equals to type in that function x minus 2 cosine x. Does anybody have any trouble getting that picture to show up right now? Okay. Next up, I do want to show you that you can zoom in at a particular instance. Let me just kind of show you what that looks like. My favorite one is to use zoom box. So if you click on one, zoom box, hit enter, zoom one. And let's say I wanted to just put a box around. Let me kind of show you what I'm going to do first here. Let's say I wanted to put a box around this region here. Okay. Then what I want to do is I want to make my cursor go to where I think with the upper corner of my boxes. I'm going to hit enter and I'm going to start drawing the box. Then I'm going to use my my arrow features to drag and create that box. And then once that box is created, once you see the box in front of you, then you hit enter again, and the calculator will just zoom in on that section. Right now, it's not. We're not having to zoom in right now, but I just wanted to kind of show you some nice features about this calculator here. So if you hit zoom one, it's activated now. So I'm going to go to where I think. So I have my cursor there. I just picked a random spot here. Hit enter, and then you're going to use your arrow. Do not hit enter again until you see the box in front of you. So you can just drag use your arrows to create the box. And once the box is in front of you, then you hit enter again, and it'll zoom in on just that one section. Right. Just want to show you that you can. It's a very quick way to zoom in on just the portion that you want to zoom in. Okay. So now I'll go back to zoom 6. Now, if you do want to make some very specific changes to your graph or to where you want what you want the graph to show you, you're going to go to Window, click on Window. You see how there are these options here: X-min, X-max, Y-min, and Y-max. So these are the only 4 values you really want to play with. X-min tells you the furthest left the graph is going to show you. So this will show you all the way to -10. It'll show you all the way to the right of +10. It'll show you a minimum Y value of -10. It'll show you a Y max of 10. Now here, my domain is from -pi to pi, so I could make this go from -pi to pi from X-min, X-max. But I like to see around my corners or my edges a little bit. So we know pi and -pi is -3.14. So if I just do from -4 to 4, it'll kind of zoom in on that place that I want to see, but I can still see around. I don't want, for me, I like to see a little bit past the edges just so I can kind of have a better feel for the graph. But you can do that here, hit enter. And this is basically the graph that we want to be able to create or that we want to be able to see once we do all of our work by hand. Okay. There's other features that I want to show you, but I think right now we'll just go to our first derivative test. But it's nice to just have your calculator to kind of confirm the picture that you're graphing. So it's not required, but I think it's nice to.
Just how easy to like solve, like.
Right. Yeah. So I mean, even if you were to graph it and this is the only thing that you show, I'm not going to be able to give you full credit, right? Your credit is going to come from your work. I'm going to see first derivative test. I want to see that you're doing everything by hand, but it's just nice to be able to get confirmation with a picture. All right, so let's go back to our paper here. Okay, I'm going to put it on a separate sheet just because I want to have plenty of room. So if you feel like you want additional space, feel free to come up and grab a scratch sheet on my shelves. Okay, so we have y is equal to x minus 2 cosine of x from -pi to pi. So we're going to go through first derivative test. We're going to find interval increasing, decreasing, relative max, relative min, point of inflection. Okay. So we're going to create a sign line first. We're going to find f prime and go through our sign line. So let's try that. Okay, so first derivative, x becomes what? Cosine x becomes, yeah, so we got to keep track of multiple negatives here. All right, so we know that we're going to find our critical points from y prime. So we can set y prime equal to 0. And this begins our first derivative test, right? We're going to find critical points, plot our slope sign line. Okay, so now we're going to try to solve for x. Two sine x equals -1. I'm just rearranging it so that I have my sign on the left side here, but basically this 2 sine x equals negative. Okay, divide both sides by 2. So now we rely on our unit circle values. Okay, so where is sine equal to -1/2? So if we think about our unit circle values, we know sine is going to be 1/2. We know that's going to be in that pi/6 family, right? I have that on the board there. Yeah, we know, so in that pi/6 family, but we know that sine, right? Where is sine going to be negative? Third and fourth, right? We know that this this acronym here, this is all trig functions are positive. Only sine is positive here. Only tangent is positive here. Only cosine is positive here. So tangent, sorry, third and fourth quadrant will be where sine will be negative, right? So we know it's going to be in that family of pi/6. So what are the variations of pi/6 in the third and fourth quadrants? 7 pi/6 and yeah, 11 pi/6. Right. So you know that third quadrant, your numerator is going to be 1 higher than your denominator, and then your fourth quadrant is going to almost be double of your denominator, but it's going to be less than that, a little bit less than double. Right. Now the issue is that 7 pi/6 and 11 pi/6 is going to be outside of our interval, right? Because we're going from -pi to pi. So the way that we can, if something is outside the interval, what can we do to this to see if we can find things that fall inside the interval? We can always do what? Find coterminal angles by, yeah, either adding or subtracting what? 2 pi, yeah. So if something is not within range, you can always add or subtract 2 pi to see if it'll create something, a variation of that value in that range. Now, we obviously don't want to add 2 pi to this because adding 2 pi is going to be even further to the right. We want something to the left, right? To the left of pi of 2 pi. So we can subtract 2 pi, see if we can find something that falls inside that interval. So subtracting 2 pi is So we have negative 5 pi over 6 and negative pi over 6, and that falls nicely between negative pi and pi. So these are the critical points we want to use, right? Everybody okay so far? Okay. So now let's create our y prime sign line. All the functions that we're going to do are going to be sine and cosine functions. So they're always going to be alternating. And also you always have the graph to kind of confirm. So really, if you can just find one to test, then the others will just alternate from that. We'll always change signs from that. So maybe it's hard to find something that lands between negative pi and negative 5 pi over 6, but we can definitely find something that lands between negative 5 pi over 6 and negative pi over 6. So why don't we do negative pi over 2. So negative pi over 2, let's insert that into this first derivative function and test that sign. And we can always confirm it by looking at the graph as well, right? So negative pi over 2 and for x, so sine of negative pi over 2, that's same thing as sine of 3 pi over 2. Sine of 3 pi over 2 is -1. -1 times 2 is -2. -2 plus 1 is negative. So we know that this is negative, which means that our graph is falling. And all the graphs I give you will be alternating. So if this is negative, you know this is positive, and this also is positive. And we can get confirmation with our graph, right? Rise, fall, rise.
We'll be like that AP exam too. We'll be alternating.
AP exam is not going to ask you to graph. That's pretty rare. But it's more like, they may give you a problem that's half finished and they ask you, certain things about it. So that's more of what you can expect on AP exam. It's not gonna be quite as extended as this. Even on the free response, this is usually not what you're going to see, but this is still really good information for us to know, especially first derivative test. Okay. So what can we expect at negative 5 pi over 6? Relative max. What do you expect at negative pi over 6? Relative min. Okay. So we're going to find those order pairs. And we can also write our intervals of increase, intervals of decrease, and we can also write our because statements, right? So let's get the hard part out of the way here. Let's find the relative max. So relative min. So anytime I want to find relative max, relative min, I'm looking for, I know all the slope behaviors now. Now I'm looking for specific order pairs. Where do I plug into if I want to find the physical location of this relative max? Back into the what? Original. Good. The original is going to give me location, right? So back to my original function here. Now, this is obviously a negative value here. Now, cosine of negative 5 pi over 6, if this feels a little bit strange here, you can always go back and see where it came from. Negative 5 pi over 6 is really 7 pi over 6, right? So cosine in the third quadrant, positive or negative? Negative. And what's cosine? What's cosine of 7 pi over 6 then? Negative 3 over 6, right? Okay, you can use your calculator to figure out what that decimal value is, and you can plot that on the graph, but I do want to see that you are arriving at these numbers, even if you are going to use your calculator to actually find that approximation. Okay, and then so we know there's relative max, and we know there's relative min at negative pi over 6. Again, how can I find this order pair? Into original, yeah. Okay. If you have trouble remembering what negative pi over 6 is, look at where it came from. It's coming from 11 pi over 6. So cosine of 11 pi over 6 is going to be the same here. There's also, well, actually, cosine is going to be positive, right? So it's going to be a positive root 3 over 2. And we have an order pair for relative max. We have an order pair for relative min. And then we can also write all of our because statements, relative interval increasing, interval decreasing, interval increasing. Okay, so we got the hard part out of the way. Let's also move into the second derivative function and find related information from concavity. So to get to second derivative, we have to start off with y prime again. And now moving on to the second derivative, y double prime. So 1 becomes what? 0, okay. 2 sine x becomes 2 cosine x. Right, so that's our second derivative function. We can set that equal to 0, create our second derivative sine line, test our intervals, and look for points of inflection. Right? Okay, so cosine of x is equal to 0. Okay, so think back on unit circle here. Where is cosine equal to 0? That's 1 and negative 1, right? Cosine is going to be 0. Yeah, so pi over 2 and what? 3 pi over 2, yeah. So we wanted to go from negative pi to pi, right? So we know pi over 2 is safe in that interval, but 3 pi over 2 is outside the interval. So we can find a variation of 3 pi over 2 by doing what? Subtract, right? Let's subtract 2 pi. So I'm just matching the common denominator here. So negative pi over 2 is valid. So we have 2 critical points that we can say falls inside the interval from negative pi to pi. So let's create our second derivative sine line. Again, the nice thing about the functions I give you will just be, there will always be alternating. So once you find one concavity, then you know the others will just continually go back and forth. So let's do an easy one here. We know 0. That's an easy one to test. We can test 0 against the second derivative function. What's 2 cosine of 0? Positive or negative? Positive, right? Positive 1. So we know that means concave up, that we're in the second derivative. We can test the other two, but The ones I give you will be alternating. So we know this is going to be concave down, but we can also test, right? Choose 3 pi over 4, and we're going to get a negative value there. So
We're not required to test on those.
right, just test one, and then and you can also use your graphic calculator to confirm your results. But yeah, I'll try to make it as easy as possible for you, but I also want to see these steps, right? So what can you expect at negative pi over 2 and pi over 2? There must be what? Points of inflection. Yeah. And then if I want to find the actual points of inflection, insert these x values back to the what? Into the original, right? Okay, so let's do that. Let's also find the y values at these points of inflection. You can also eventually you're going to use your calculator to get that decimal value, but I do want to see the exact value worked out by hand. So I'm just inserting it back into the original function here. So that's convenient. We know that this is essentially 3 pi over 2. You know, cosine of 3 pi over 2 is going to be 0, so that's going to 0 out. I'm just going to be left with negative pi over 2 as the y value as of one of my order pairs. Again, cosine pi over 2, that's easy. That's 0. So it's just going to be pi over 2. Okay, so let's just get some ballpark values here. You can use your calculator to find what these values are. But this one is going to give me something around around -1. This relative max is going to be around -2. And negative pi over 2, that's around like -1.5. Again, you can just, if you replace pi with 3, then that will kind of give you a ballpark value. We're not looking for exact, so this is 3 over 2, that's around 1.5. Okay, so we're going to try to sketch our graph here. I think it also helps to find what the endpoints are sitting at. So f of negative pi you can also do this. You can also make the calculator find those endpoints for you. So if you do second trace, you see that word value there? If we do second trace value, you can just type in any x value, and it will give you the y value in return. So if I do negative pi, now pi is the button next to that caret, right above the division sign. If you do second caret there, you see that negative pi. It gives you negative 3.14. If I want to find my other endpoints, again, if you do second trace value, and this time I can just plug in pi. It'll give me my other endpoint, which is also 3.14.
Is that like a interval like pi 3.14 is
Oh, right. So that's my order pair. So basically negative pi comma negative pi, and then pi comma pi. It just so happens that there's just coincidence that the x and y values are the same for those points. Okay, so we're just basically sketching this graph that we see in front of us here. That's all we're doing. But we're backing it up with all the work that we've done. Again, I'm not looking for exact, if you have a ballpark value, that's good enough. We know the graph is going to rise to a relative max at negative 5 pi over 6. And then we know that it's going to hit a y value of -1. And it's going to decrease until it hits a relative minimum at -2, at negative pi over 6, -2. And it's going to rise the rest of the way. We know there's a point of inflection at negative 1.5 and 1.5. And we know our graph is going to start off concave down, then concave up, and then concave down.
You don't put arrows on the end, right?
I'm sorry?
You don't put arrows.
Right, we don't put arrows at the end because the graph tells us the endpoints.
You hit like Tues because statements.
That's right. We'll do the because statements as well. Another feature that I want to show you here is that you can make the calculator find the relative max and min for you, just to help confirm your work. But again, if you do everything from the calculator, that's not enough. I want to see. I need to see all the work here. Okay.
Check that, that's right.
That's right. You can also. That's right. Yeah. Perfect. Yeah. So definitely use your calculator to confirm all your work, but the calculator alone is not enough. If you're I need to see the work backing it up. So let me kind of show you what I'm going to do here. There's a feature called relative max and relative min, where we can actually make the calculator find that relative max and relative min for you. But what we're going to do is we're not actually going to go make the cursor go to that relative max, relative min. What we're going to do is we're going to make the cursor go to the left, pick a point to the left of it, and then pick a point to the right of it, and then the calculator is going to find that relative max for you. Okay, so I want to have us practice it. Again, it's not required right now, but it is a very useful skill, especially second semester. But we can kind of practice that now. So what we're going to do is you're going to go to second trace, and value will help you find any y value you're looking for given the x. 0 will help you find x-intercepts. Minimum will help you find a relative min, and maximum will help you find a relative max. And if you have two separate graphs and you're looking for the intersection, then you can click on that intersection. Okay, but we're going to start off by looking for a relative max. So we're going to go to option 4, and you're going to do maximum. Okay, but again, don't let the cursor go to where you think the maximum is. Then the calculator will get confused because you want the calculator to look for the maximum. You're not going to look for it for the calculator. So you're going to just pick a point to the left of your relative max. So just pick a point to the left of it. Hit enter. You see that word left bound there? That means it's asking for the left of your relative max. Hit enter. And then it says right bound. So now you're going to scroll to the other side of your relative max, but don't stop at the relative max. Go to the obvious, close enough, but not too far away. Hit enter again. So now it says guess question mark. Now the calculator is going to take those 2 points and it's going to look for the relative max between those 2 points that you gave it. is going to find that point. Okay, and that relative max is at negative 0.889885. The x value is negative 2.65, and that negative 2.65 is going to be roughly around that negative 5/6. You can use your calculator to confirm it, and it's just nice having your calculator to confirm all the work that I'm going to ask you to do. Okay, so now using our sign lines, we can fill out all these because statements, right? So let's see if all of this makes sense, right? Because now's the easy part. Now you can just write everything forward from your sign lines. So our interval of increase, always use parentheses. And I'll make sure that you're giving me because statements. On the curve sketching test, what a lot of students were doing were either they were not giving because statements, or it was because statements that did not have the appropriate notations. You have to tell me f prime is greater than 0. If you say the graph is greater than 0, or the slope is greater than 0, or the derivative is greater than 0, that's not good enough. Okay, I'm looking for a very specific. Name that function for me and in your because statement. Interval decreasing, pull that from your sign line. Relative max, because f prime changes from positive to negative. So allow students just say because sign changes. Okay. Again, you'll lose a point if you say that, right? Because f prime changes from positive to negative. Relative minimum, because f prime changes from negative to positive. Concave up, because f double prime is greater than 0. Concave down, because f double prime is less than 0. Point of inflection, because, some students say this. Some students say point of inflection because f double prime is equal to 0. That's not good enough either. You got to say f double prime changes signs. Yeah.
You do brackets.
Everything parentheses.
Okay.
Yeah, everything parentheses. That's, you know what, I think there's some debate about that being brackets or parentheses. I think you can. Yeah, I probably won't take points off if there's brackets, and I don't think College Board will either, but it just makes more sense parentheses for me. But I think pre-calculus, they are having that discussion whether to use brackets or parentheses, but you won't lose points for parentheses, so I'm just always going to say parentheses. Right, but hopefully we find this to be the easiest part of the problem, right? If you have the sign line in front of you, then it's just writing these out. But I hate to see students keep losing points because of the because statement. So just make sure that you're clear on how what I'm looking for with those because statements. I know this is a lot. But I am giving you a calculator, so hopefully that will kind of help you feel like you have some backup, especially if everything gets so messy with the numbers. And also, I also want to make sure that I had plenty of review days. So having 4 review days to be able to do one of these every day, I think will kind of make it a little bit more familiar and won't feel as difficult if we can do this, if we do one of these every day after we get through our new topics.
So is there gonna be additional topics with this?
I'm sorry.
Is there gonna be additional topics like to add on to it's? No, it's just the what we're.
Oh, no. We still have 2 more things. We got to do related rates, and we have to do mean value theorem, which is related to this, and then also inverse trig derivatives, but we'll be able to get through all of our new notes by next Monday, and then next Tuesday through Friday will all be just review.
We say this thing the students are working those, like this.
I'm sorry?
We say this is the thing the students are working those.
Yeah, but I think in the past, it was non-calculator. So I'm giving you a calculator to hopefully that will kind of give you some, yeah, it's just I feel like that's a nice safety net, even though I'm asking for all the work, but having the calculator, I think will be very helpful. I'd like for us to practice a few more things on the calculator. I also want us to practice finding the relative minimum on the calculator. So again, the same process where you do second trace. And now you're going to pick the minimum feature. And then you're going to go make your cursor go to the left of your relative minimum, hit enter. And then make your cursor to the right of your relative minimum, hit enter. And hit enter a third time, and the calculator will find that relative minimum for you. So you guys can try that now. I want to just kind of circle the room and make sure that you're comfortable getting and just feeling your way around the graph. I think this will be a very good knowledge for us, especially second semester when we're having to do more graphing, but this is a bit of a preview as well into next semester.
I don't know how to get good enough to go with good. Let's go right.
Okay, so you can go to window here. See the X-min, X-max.
Yeah.
Just make it go from -4 to 4.
Well, I was trying to do that, but it doesn't say.
Hit enter or hit graph. Oh, no, we don't really, the Y-min, Y-max is fine, leaving it -10 and 10, so because this is only the X values here, you don't. So go from, make the 10, make the complement, hit graph now. It's pretty close. And now I can do second trace minimum. Go to the left of the row, hit enter. It's just keep going to the right. Okay, hit enter now. Hit enter, not hit enter, third time. It's gonna find it for you. Hit enter. Oops. Okay, let me show you how. It's like you're gonna go to the left of the row, then hit enter. Go to the right, hit enter again. And it says guess, so hit enter again. Don't move the cursor anymore. It's gonna, the cursor's gonna find that relative in for you.
Sure.
We have a larger. Okay, sorry, so you just. It's your third time. Okay, I'm gonna continue circling the room, but you guys can come get your phones. So let's use let's use the left of the row. So we're to the right of the row. They just now right now. They enter third time. Yeah, so you can start X minus. It's not the same down. You can also then
I was gonna ask.
hit enter a third time. I think minus this, that's not, this is correct. This is,
No, okay.
You have that extra paper for the words?
Oh, yeah, sorry, guys. I do have that extra worksheets. If you want to pick that up. Here's worksheet 5, guys. Help session tomorrow morning, 7:15.
Yeah, I got hundreds. Today, new graph, yeah, where she brought. Oh.
Let's say you want second phase. So. He's definitely not going to be. Every mag of that show. I'll think about that.
Not great wine as it is.
So that's my max. It's our third time. Now it has my influence. So you can compare again.
Okay, you don't move it anywhere else.
Yeah, just left and right. I think our third time. And so.
Save for a minimum. That's right. Thank you. I'm like, I'm doing this on my house.
Got it.
I see need a graphic one first.
Yeah, well, you don't need it, but again, it's really helpful.
Okay.
Yeah.
You can't do it on the, you can't do this on the TI-36.
You could, but it's just very cumbersome because you're only relying on table of values. And it's harder to, it's a lot harder, a lot more cumbersome than this would be doable, but it's just so much easier. I've seen the graph in front of you.
So you can do it on your own, but you just can't see a picture of it.
You can't see a picture, right? You're just given a whole bunch of order pairs. That's it.